last class I started with I have discussed about the numerical, how can you solve some if someone give numerical related to light emitting diode, right? So laser is the one that this is the one of the light source material which can be used for the different application. You can see the laser, the full form of the laser is the light amplification by stimulated emission of radiation. Okay, so that means you need some amplification. Okay, and what is the difference between, if you think about the what is the difference between the LED and the laser diode? So main is that it can produce the coherent light and the narrow beamwidth. Narrow beamwidth means if you plot the intensity versus the wavelength graph, versus the wavelength graph, then you get a narrow spectrum region for case of the laser, but for case of the LED you will get a this much. So you have the narrow, if you have the narrow beam width, that means the intensity will be more for case of the those laser. Coherent light that will come in the I'll discuss in the next slide. That means it can produce the same amount of the photon, same energy of the photon, and multiple number of the same energy of photon or same wavelength of the photon can produce by the laser, that is the coherent light. Okay. So it has the high power. As the beam width is narrow, then you can automatically see that the power is also more if you get the high power from the laser. For case of the LED, you can see the low power as compared to the laser. Okay, and now come to the in the optical fiber communication, laser can be used for the transmitter side. When if you need the high power transmission, then you need the laser. So you can design various kind of the laser, the semiconductor laser, and semiconductor laser that is on a most powerful power, that is like a 20 milliwatt. These are available nowadays. So there are the various semiconductor lasers which can be used for the optical communication. Okay, and the so as the narrow, the beam width is narrow. Okay, the laser beam width is narrow as compared to the LED. Then the laser can easily couple with the optical fiber. So if you connect the laser, you can easily connect the laser with the optical fiber. So this is your optical fiber. So easily you can couple the laser with the optical fiber. But in case of the LED, it's very difficult to couple as compared to the laser. So if you couple properly the source and the optical fiber, there will be less degradation of the information while coupling. Okay, so these are about the laser. Now come to the working principle of the laser. So the absorption and the spontaneous emission, these two are used to happen inside the LED also. Absorption and the spontaneous emission. But case of the laser, that this is added. Okay, the stimulated emission, it is added. So just addition of the spontaneous, along with the spontaneous emission, we have the stimulated emission. Okay, and this stimulated emission. Now you can see here, this is the so there is a band gap, that is the low ground state, and this is the accelerated state. E0 is the ground state and A1 is the accelerated state. What is the absorption? Absorption means, so when any if we accept the electron by optical energy, we accept the electron by optical energy, then the electron will go from lower state to higher state. So after absorption, it will happen. Electron will go from lower state to higher state after absorbing the photon or any optical energy. So after some time, this electron will not stay forever. So this electron will be stay for some time, but it will not stay for a longer period of time in the upper state or accelerated state. So it has to come into the ground state. So what will happen if it will come from the upper state to ground state? Then it will emit a photon. Okay, so this is called the spontaneous transition from ground state to higher state absorption, and the transition from higher state to ground state, that is the spontaneous emission. Along with the spontaneous emission, there will have a stimulated emission inside the laser operation. So stimulated emission means, so suppose here the photon fall into the ground state. Sometime it will happen, it will not directly fall into the ground state. So it will release from the upper state. The photon will release from the upper state, but you have to create one active media so that this photon will for traveling forth and back. Okay, so it will move this side and this side. So what will happen? Again, this photon will this photon. So this is the photon. So rather coming into the lower state, it will again go to the opposite side. Again, it will come back and it will generate due to this photon. Due to this photon that is a one of the optical energy. This photon also helps to excite a one more electron from the ground state, and one more electron will come from the upper state. It will go ground state to upper state and upper state to and the ground state. So at the same time, this photon as well as the whatever photon is produced now, both the photon will emit from the device. So that means in this spontaneous stimulated emission, so one more photon will excite the electron, one more electron, and at a time two electron can emit from the device. So in this way, not only two electron will emit from the device, so lots of photon can emit from the device. So we have to maintain a system such a way that so whenever a photon will want to radiate from the device, so all the photon will not emit from the device. So yeah, those photon will be stay inside the device for some time, and those photon will help to produce the extra number of the photon from the device, and all the substantial amount of the photon will produce at the same time. The 10 amount of photon will be come out from the device. So that means it will create a coherence also. At the same time, the maximum number of the same wavelength photon can come out from the device, which can produce the high power. So this is about the stimulated emission. So in next lecture I will also discuss about this thing elaborately. So for achieving the laser operation, for achieving the laser operation, or it is called as a lasing operation, so you need one thermal equilibrium system, and you need a population inversion. You need to create a population inversion, and you need to apply a pumping. Pumpers will tell the pumping. So what I told that at the same time, a maximum multiple number of the photons should emit from the device. So for achieving those phenomena, how the maximum number of the photon will produce from the device. Okay, from the device at the same time. So for that we need to apply pumping. Pumping means what? Before pumping, I will tell the population inversion. So population inversion means, so in the ideal case, the maximum number of electron will be in ground state, and the minimum number of electron will be in upper state. Okay, but you should create a maximum number of photon. When it will be possible, when the maximum amount of the electron will come from the upper state to ground state, then only that it is possible. Okay, so for that, so means we have to create a maximum number of the electron inside the upper state. Okay, we have to create a maximum number of electron inside the upper state. That phenomena is called the population. When the condition happen like that, the higher energy level will have the majority of the photon as compared majority of the electron as compared to the ground state. Then only there will be have chance to produce a maximum number of the photon at the same time. So this process is called the population inversion. How it should possible? Okay, maximum number of the electron should be created inside the higher state. So using the pumping is the process, okay, by which the you have to apply some pumping or optical energy, so that at the same time the maximum number of the electron will produce in the upper state. That is called the pumping. That means before the lasing operation happen, we have to uh, move the number of photon from the ground state to upper state. That is called the pumping. So first the process is the pumping. So once the pumping process is done, then the population inversion will happen inside the system. So that population inversion means more number of the electron or atoms will be presented inside the higher energy system. So that is the population inversion. Then what will happen? So it may possible that all the photon will come out from the higher, will fall down from the upper energy state to lower energy state. But you have to create a active media so that those photons will not come out from the device. Those photons will again move or oscillate inside the device, and at the same time, it will, the suppose 10 number of photons are there. So 10 number of photons will oscillate inside the device, and those 10 number of photon will produce the more 100 amount of the photon, and all the 100 amount of photon will come out at the same time. That entire phenomena is the lasing operation. Okay. So the more main features of that, the identical wavelength. So all the wavelengths, whatever photons are coming out, come out from will come out from the device. Those wavelengths will be the same wavelength, and it will produce a narrow beamwidth. These are some features. Okay, so this I've already discussed. So main working principle, under the working principle, you have to first process is the absorption. So first you have to make one active media, or it is called as a gain media. Okay, active media or gain media. So inside the active media or gain media, we have the semiconductor. So for that, we need to for activating the absorption, we need to apply the pumping. Pumping means at the same time, the maximum amount of the photon will come from the will go from the lower energy state to upper energy state. That constitutes the pumping. So pumping will be under the absorption mechanism only. Okay. Then the spontaneous emission. Okay, then spontaneous emission. For this case, the excited amount of molecule eventually return to their lower state. Spontaneous emission, this I have already told. The some photon will come from the upper state to lower state, which will produce the incoherent light. But this incoherent, that means the different time, the different amount, then the different wavelength photon will come from the upper state to lower state. So these the wavelengths are not in the same, and their phase are also not in the same phase. But this phenomena also happen inside the laser. But along with this phenomena, the stimulated emission also happen. So for the stimulated emission, we have to create the gain media and the population inversion. The stimulated emission already I told. So suppose one photon will while going back to the ground state. So this photon will not go to the ground state. This photon will uh, system will produce a photon, and this photon will move and oscillate front and back, and this photon again will help to produce one more photon, and both the photon will come out from the device. This process is the stimulated emission. This is explained here only. Okay, that means both the photons wavelengths are same, and both will have the same phase. So this is the stimulated emission. So if the stimulated emission happens, then there will be the amplification of the light. So we need a optical feedback or gain media. For that I have already told. So that at the same time, the more number of photon will be produced using the for amplification. So for that you need to create a one media, so that the photon will not come out from the device. Photon will be travel forth and back. Okay, so this is called the optical feedback. So it is not once the photon is released, produced, this will not come out. So this will create a feedback connection. That means this will again help to produce a one more photon. Okay, so this is the optical concept. This concept is the optical concept. So once so there will be the reflective index in the both side. So the photon will try to match with the reflective. Once it is matched with the reflective index for all the photon, then all the photon will come out at the same time. Okay, so which will produce the coherent and the collimated and the highly monochromatic light. Monochromatic means the single wavelength. On the same wavelength, multiple photon will produce, which will travel in a same phase. So this will be the laser output. And the population inversion, this I told, the population inversion, the higher amount of the photon will be presented inside the higher energy state. Okay, so these are the steps we have to follow. So what are the steps you have to follow? These are the phenomena, these are the mechanisms are there inside the laser. And what are the steps you have to follow? The pumping. First is the pumping to to produce the photon atom on the upper state. That is the pumping. So once the more number of the photons or more number of the atoms are reached into the accelerated state, that then the accelerated state will become a population inversion. Then that stimulated emission happen, stimulated emission, and then those suppose two amount of photons are produced in, so the stimulated emission, those two amount of photon will be in this stay inside the device only. So for that you need the optical feedback. Okay, so those amount of photon will be travel and oscillate inside the device. then these two will photon will produce a more phone number of the photon, and all the phone number of photon will be come out from the device at the same time. So this is the laser effect. So for that, here suppose this is the active media, this will be fully reflecting, and this will be partially reflected laser, because from this side there will be a small hole. From this hole the first photon will try to match the reflectivity of this mirror, and after that, and this all the amount of the photon will come out from the device. So it will be designed such a way that at the same time maximum number of the photon will come out from the device. So laser emission. These are the steps are there for laser operation. Okay, so whatever I discussed, same thing is mentioned here. There's a metastable state we can create so that higher energy in a metastable state also, the non-radiative. So sometimes it happens, so suppose 100 amount of electrons are produced inside the higher energy states, or not all the 100 amount of photon will not help to produce the photon. Okay, so some amount of the electron will come into the metastable state, which can produce a non-radiative recombination. So this is for normal case, and this is for the laser system. So you can see what is the difference in this photon. So once the photon, this photon will happen, this photon again move, travel, oscillate inside the device, and this photon will act as a laser photon, and this laser photon again hit the outside the electron, which will go to the upper state, and both the electron will come out, both the photon will come out from the device. So these are the some characteristics of the laser diodes, suitable and higher bandwidth. You can see the higher bandwidth, and it is very fast response, the 1 nanosecond, and it has the optical bandwidth of 2 nanometer. And it can easily couple with the optical fiber, so then it can produce a higher amount of the power. Okay, so if the optical fiber core is a very small size, it can easily couple with, laser can easily couple with the optical fiber. Okay, so this phenomenon, laser the fabricated resonator and the distributed resonator, this I will discuss in the coming lecture. Please like, share and subscribe my channel. Thank you.